Here's a contrived example of a light bulb with a couple of toggle buttons for operating. There's a power toggle, turns it on, turns it white. We hit it again, it turns it off. We can turn it on, and then we can hit the color toggle, turn it red. We hit it again, it turns it white. Turn it red, turn it off, turn it back on, it always comes back to white. Next, we make a second light bulb by inheriting from the first one. We hit the power toggle on the first one, it turns white. We hit the power toggle on the second one, it turns red. What just happened? Why is light 1 white while light 2 is red? The code for the light bulb class says that it will turn white when turned on. The secret is that we changed something when we created light bulb 2 by inheriting from light bulb 1. In the process, we overrode the toggle power method of the superclass. We turn the default to red. This creates a surprise. How do you debug this? Should a child subclass be allowed to override methods of the parent superclass? If so, exactly which methods? What is expected here? In some cases, we want to build new classes by subclassing them and changing the details. In other cases, we don't want to allow this much freedom. Imagine that we draw the intended behavior as a diagram on a whiteboard. When we look at the top level of a diagram, we want to know what happens. We don't want to have to dig through all of the children's subclasses to figure out what happens. We want to know that in the future, nothing can change this behavior. We might draw the top level diagram like this. 2 states, off and on, and then the power toggle goes from off to on, and then we hit the power toggle again, it goes from on to off. And we might draw the color toggling child diagram as this. 2 states, white and red, and then the color toggle goes from white to red, and then when hit again, it goes from red to white. The diagrams say that the color toggling code does not affect power toggling code. In fact, we would want our development tool to check and alert us when any child diagram touches control flows that are already handled by parent diagrams. Again, this is but a contrived example to show this problem as simply as possible. There are ways to write the code as text so that this particular example does what we expect. To my eyes, the diagrams make more immediate sense than reading the code does. The top-level diagram implies that no child will ever be allowed to override the will of the parent. In this contrived example, a child is not allowed to override the meaning of the power toggle method. The problem of overriding goes even deeper. Let's say that we write code that mimics the above behavior of the diagrams, i.e. both lights turn on to the white state. The child subclass is written so that it does not alter the behavior of the power toggle method. Yet, there is no guarantee that a future addition to the code will preserve this structure. Maybe a month from now or so, someone will add subclass code that does override the power toggle method. Based only on inheritance, the system cannot alert the programmer that the new subclass violates a design rule. The program is surprised and must debug the situation. Yes, we can add further bobbles to the textual notation to insert generalized code for better type checking, but the diagrams are more expressive. Most normal humans understand what the diagrams say. Textual programming languages violate such inherent understandings. I'm not advocating that we get rid of inheritance and simply replace it with parental authority. In some cases, inheritance makes more sense than does Paroth. In other cases, Paroth makes more programming sense than inheritance does. The decision of what kind of mechanism to use, inheritance or Paroth, needs to be left up to the software architects. They should decide what is best for their design space. Language designers should provide tools for software architects that do not deflect them from using the most appropriate kind of solution for their problems. Diagrams should mean what they obviously mean, always. No future additions should change the meaning of any layers above them, ever. If you look at Borel's state charts, you can see parental authority in use. That paper was published in 1986. You can also see other effects happening, like recursive entry into states and reverse exit out of states. This kind of stuff can be expressed in text as finely blocks into first statements, but again, the diagrams are more expressive. If you make inheritance work the right way around, i.e. using power off, and you do a few other things, you can begin programming using diagrams. VPLs, visual programming languages, including simple node and arrow diagrams, have gotten a bad rep because of the lack of power off, lack of extreme decoupling, and lack of ports, lack of asynchronous concurrency, lack of layering, etc., etc., etc. VPLs built with current textual methods simply don't work very well. They tend to be visualizations of textual programs instead of being programs in their own right.